5.7 is what we're going to do now. It's solving quadratic equations using the factoring method. So we're going to give a try to that. And we've been practicing our factoring a lot, so we'll be ready to use it. Okay. And so it comes from an idea that you could think of yourself. And that idea is called the principle of zero products. Some people call it the zero products principle. Some people call it the zero products property. Whatever, it doesn't matter. But the idea is really simple. If I tell you I have two numbers and I multiply them together and the result is 0, then you know something, right? What do you know? Think about it. Yeah, you know that one of them has to be 0. So that you know that A equals 0 or B equals 0. And that's the zero products, right? And so that's the story on that. And A 0 is really unique, right? If I told you that I'm thinking of two things and I multiply them together, I don't get my B there, I don't know why, times B, right? And I get, say, 6, right? Well, you can't tell me for sure anything about the numbers. And so, I mean, there's a zillion, bazillion possibilities. There's a lot of possibilities here, but they all involve either A being 0 or B being 0 or both of them being 0. And so like A could be 0 and B could be anything on earth, and then this would be true. Whereas here, A could be anything on earth and B would be something, right, that makes 6. And so you just can't say something about one of them. Like A could be 1 and B would be 6, right? And A could be 1.5 and B would be, I picked a not nice one, right? 4. And A could be 1.0001 and B would be, and on it goes, right? It would be this. I can't even write it down. But, and when I multiply them together, I get 6. So I can make a list that's gazillion long, but this always has either this is 0 or that is 0. So it's really, really special. Okay, how we're going to use this is that we're going to write things as a product. So A times B is a product, and the product is 0, right? So if I have a product, so this is a binomial times a binomial, and I equal 0, then what that tells me is either A plus 3 equals 0, or A, X plus 3 equals 0, that piece equals 0, or this piece equals 0. And then that allows me to pull it apart to be two things I already know how to solve, right? By using the 0 property. And so I pulled it apart and I know how to solve this. You take away 3 from both sides of the equation. I solved these in chapter 1, right? And this gives me X is negative 3 as X equals negative 3. Where did my equal sign go? I have my thoughts going. Or, and then if I take away 2 here, to leave X all by it, X equals negative 2. Now, truly it's or, because X can only be one thing at a time. And so I just want to show you how negative 3 is the answer. So if I put in negative 3 here, I have to put in negative 3 there, right? So I just want to check it just so that you can see how they both work. So negative 3 plus 3, negative 3 plus 2 equals 0. You have to put in negative 3 in both of them. So this is 0. And whatever the heck this turns out to be equals 0. So it does turn out to be negative 1, and 0 times negative 1 is 0. So that's how it worked, is it made one of the pieces 0 so that when you multiply them, the product is 0. And if you go check negative 2, you'll see that it works the same way. I got my fat pencil working, right? The wide lead pencil. I like it though. I don't break the lead as often, but it is a little bit wider. And so here I get 1, and here I get 0, right? And then when you multiply them together, you get 0. So that's how it works to solve the problem, by making one piece be. And now this one they factored it for me, and they factored it into a product of 3 pieces. So they have a monomial, a binomial, and a binomial equals 0. And they factored it into 3 pieces. So 3x equals 0, or 2x minus 3 equals 0, or 3x minus 4 equals 0, right? And then I'm going to solve those. So I want to solve for x, so divide by 3. 0 divided by 3 is 0. So that's one of the answers. Or add 3. So I get 2x equals 3. Divide by 2. X is 3 over 2. Add 4. 3x equals 4. Divide by 3. X is 4/3. And you can see how each one of these answers, there are 3 answers, and you have to give all 3 answers, just like here there were 2 answers and you need to give both. And you can see how each one of these 3 answers make it work, right? If you put in 0 here, you get 0 on the outside, times this is not 0, but it's whatever number it is. And this is not 0. When you put in 0, 3 times 0 is 0, but minus 4. So this is negative 4, and this is negative 3. So when you put in x is 0, you get 0. 3 times 0 is 0. 0 times negative 3 times negative 4 equals 0, because one of the pieces is 0. If you put 3 over 2 in, 3 over 2 times 2 makes 3, and 3 minus 3 is 0. So out here you get something that's non-zero times non-zero, which is 0, and etc. So that's how it works to solve the problem. Now, what was nice about number 2 and number 12 is that some sweet somebody, factored it for me. You probably recognize this as things that we were factoring in chapter 5, right? Which we're still in chapter 5. But you factored it and it looked like that. Or you factored it and it looked like that. And so all we have to do is work on getting it factored. I wonder who that is. Probably a telemarketer. It is. It's the survey people. They want to know, who am I voting for, right? And the answer is Mickey Mouse. I'm going to write him in. No, he hasn't been working in a while, right? Disneyland's been closed for a long time. Maybe I'm going to have to think of someone else. Maybe Charmander. And so that would be a good president, right? Charmander. So the solving strategy for solving quadratic equations. So I hadn't told you that the name of these type of equations are called quadratic. And this is what a quadratic equation looks like. ax squared plus bx plus c equals 0. And it could have some missing pieces, like the middle could be missing, or the end could be missing. Or, but if it's quadratic, it's degree 2. And so it won't be the front that's missing. And so degree quadratic means degree 2. So I always ask students, I always say, why do they call them quadratic if it's degree 2 equations? Because it seems like quad means 4. And so wouldn't that go somehow with 4? I mean, I wasn't the person that named it. And it was, when they were discovered, quadratic equations, they were trying to solve something with a square. And so a square is a quad, has 4 sides, and a rectangle. So they were trying to solve problems with area where they had x like that. And when you find the area is x times x, which is x squared. And so that's how they kind of got their name. If you don't believe me on that's kind of how they got their name, go Google it, and you can read about it. But it came from somehow looking at finding the area of a rectangle or a square, and quad meaning 4-sided. Anyway, so that's how it got its name, quadratic. I wouldn't have named it that. I would have named it degree 2 equations. This method that we're learning also solves degree 3 equations, and we're going to see a couple of those. The strategy, though, is to get 0 on one side. You want your lead term positive, and that's called standard form when you get it looking like that. So you want it in descending order, you want your lead term positive, you want 0 on one side. The second step after you get that done is you factor it. And then you use the 0 factor property, or the principle of 0. What did I call it here? 2 different books, right? The principle of 0 products, same thing, 0 factor property. Basically, it set the pieces equal to 0 and solve the resulting linear equations, and then check. So we're going to give a try to this, and we'll see how we do. So the first thing I notice is that it is degree 2, right? So this is how you solve equations that are degree 2. We solved equations that were degree 1 in chapter 1. So they didn't have the x squared part like that. And there was a different strategy for solving degree 1 than there is for degree 2. So for solving degree 2, the first step is to get 0 on one side. So I'm like, hot diggity dog, I have it. Then you factor it. And so how you factor it, when you get to the F word, right, factoring it, is you say to yourself, well, what type is it? And my choices are binomial, trinomial, or has 4 terms. Those are the 3 main types that we learned to solve. And you always start off, whenever you're going to factor it, no matter what size it is, right? So factor the trinomial, in my case. But no matter what, you think greatest common factor. So that's where I'm on. I'm on step 2, which is factor it. It came ready to go. Number 1, step 1 was done, right? So I want to get it factored. It's a trinomial, greatest common factor. Well, the greatest common factor is 1, so do nothing. Step 2, unfoil. So I'm thinking x times x and 1 times 5, right? Those are the only ways. And they have to add to be 6. Oh, yes. And in fact, they need to add to be negative 6. So that tells me this sign says they're the same sign. This sign says they're both negative. So we're going to have x minus 1 times x minus 5 equals 0. Then you set the pieces equal to 0 and you solve them. X minus 1 equals 0, or, it's truly or, x minus 5 equals 0. So that's the 0 factor property, or the principle of 0 factors, or set the pieces equal to 0. You have to have 0 on one side or this doesn't work. You add 1. You get x is 1. Add 5. You get x is 5. Those are my 2 answers. Quadratic equations, degree 2, will have 2 answers. So, and then the 4th step, so we did our factoring, right? We set our pieces equal to 0. We did a really good job. The 4th step is to check. So I want to check. Over here is my thoughts, right? My thoughts are kind of wild right now. I have ice cream in them right here. So when you check in the original equation, x squared minus 6x plus 5 equals 0. So I'm going to replace in here. And you check them one at a time. So I'm going to check 1 and see if it works. So I replaced in 1, x is 1. And you could use your calculator if you like. When I tell people it's okay to use their calculator, then they're like, oh, we should use our head. And if I tell people, do it in your head, then they say, oh, you won't let us use our calculator. So I can't win for losing my friends. And so I'll allow you to use your calculator. Certainly on checking, I haven't used my calculator up to this point on this problem, right? So I think it's a really good idea to get it involved. And I expected to get 0, and I did. So I'm like, hot diggity dog, 0 equals 0. And I'm like giving a smile to the whole world there. And here was me checking the first solution. Now I also want to check x is 5. So I'm going to plug in x is 5 to check it out too. Both of them should work. So I'm putting into my blank 5. And I'm going to come in here, and where I have 1s, I'm going to replace it with 5. So I deleted back over it, and I should get 0, and I did. And so that just tells me I didn't make a mistake. If it didn't check, then I made a mistake. So it has a solution. The solutions can be found, and you made a mistake somewhere if it doesn't check. So sometimes people tell me when they check it and it doesn't work, they write me a little note saying, you messed up on this problem. And it's certainly true that I could make a mistake on a problem, but they should have an answer. So if you found an answer, and it doesn't check, then you have a mistake on the problem. Now, they might have an answer that can't be found by factoring, but they all have an answer. We're going to see that. By chapter 10, you'll be convinced. So I'm looking at this one, and I'm noticing it's degree 2, right there, degree 2. This is degree 2, that's degree 0. So the highest is degree 2. So that tells me to solve, this tells me, this is my thoughts, right? Oh, it's the type of equation is degree 2. That tells me get 0 on one side. That's the strategy. So this is your thoughts when you notice it's degree 2. Get 0 on one side. You have a different strategy when it's degree 1, which is what we learned to solve in chapter 1, was ones that are degree 1. You might have learned another method on a problem like this, and I'm okay with you using it, but I'm pretty harsh if you mess it up. So in other words, you might want to wait. So anyway, if I want to get 0 on one side, this is the leader. And so the leader is all positive, and I want the leader to be positive. So I'm going to try to make this side be the 0 side. And so I'm going to take away 25 from both sides. And I want to write the other side in descending order. So I got 9t squared minus 25 equals 0. And then I notice it's a binomial because I'm on step 2, right, is factor. And so I get to whip out the F word, factor, right? That's what I'm saying to myself that I need to do. And I notice because it's a binomial, I always think greatest common factor, always. But the greatest common factor is 1. So the next thing I think, because it's a binomial, is it a difference of squares? And I'm like, hot diggity dog, that's a difference of squares, right? That's a PS, a perfect square, a minus, and a PS, right? So I think, how does this going to factor? And so I'm going to go in here, and this is in here, this is 5 with my dull little pencil, and in here is 3t, right? So you add them and you subtract them, the bases, right? That's how you factor the difference of squares. So add them, 3t plus 5, 3t minus 5. Then you set the pieces equal to 0, 3t plus 5 equals 0. So we get 3t equals negative 5, dividing by 3. T equals negative 5 over 3. That's one of the answers. And then and then the other answer, 3t minus 5 equals 0. So you add 5. And you divide by 3. So those are my two answers. Because it's degree 2, I expected to get 2 solutions. And I'm going to show you when you don't get 2 solutions. But most of the time you get 2 solutions. But there is occasion when you get only 1 solution, and I'm going to show it to you. Anyway, what happens to people when they use a different method on this is they give me just 1 solution, and they give me this one, or they give me that one. Usually that one is the one they give me. And I have my points set up on my rubric for if you had done it the way that they were showing you how to do it. And so I have getting it factored as some points, and then having set the pieces as some points. And so, and then solving them out, right? And so if you do it a different way, then you haven't done, I can't say they did that part, whatever, because you did it a different way. And then if you goof it up, then you don't have the partial credit. Now, if you do it correctly, then I say, well, they did it a different method and they did it correctly. Anyway, that's how I look at it. So you lose your partial credit if you don't do it the way that they show right now, just because of my rubric. So I'm just warning you on that. Got 0 on one side, and I see that it's quadratic. So I'm like, okay, hot diggity dog, but this needs to be in descending order so that I can do the second step, which is factor it, right? So the first step is get 0 on one side, get 0. And actually, they also kind of said, put it in standard form. And standard form is descending order. So I don't care if you say that, when you get here to factoring, if you say, oh, well, in order to factor it, I got to get it in descending order. It doesn't matter to me. Standard form is descending order. So you got to get this in descending order so that you can factor it. And you put it in order by the largest x, degree 2, x, degree 1, plus 9, this is degree 0. And then you factor it. This is a trinomial, and how you factor a trinomial is always everybody is greatest common factor, right, which is 1. And then you unfoil because of the size. Size matters on factoring. 9 could be 3 times 3. Those add to be 6. So, and they're both positive. So this is x plus 3. Remember, this tells me that my things have the same sign. This guy says they're just like me, and so he's positive. So x plus 3 times x plus 3. And so this is a time when you're only going to get one solution. Because you see, when I set the pieces equal to 0, do you see how these are the same? As this. So if you told me that this is the solution, right, and you circled it like this, and you said this was the solution, I will smile at you, because it's like writing the same sentence twice in your essay. George Washington was the first president, period. And then you say, oh, that was such a good sentence, I'll just write that again. George Washington was the first president, period. And so you don't write it twice. You just write it once. X is -3. There is just one answer. People ask, you'll put a smiley face, but will you mark it wrong? And the answer is probably not. I'll probably just write a smiley face. And so, but there is just one answer, and you do want to know that there's just one answer. And so anyway, so that's kind of the story on that. This is example 4, and we're doing quite a lovely job on these examples. I don't think I've had water today. I've had quite a bit of tea, but I've been making video after video from sun up to sundown, and pretty tired, and I think I drank about a gallon of tea. So I might have to go to water at this point. So I'm telling you my stories, right? So it's degree 2. So this is degree 0, this is degree 1, this is degree 0. So things that are degree 2, when you have something that's highest degree is 2, then what you want to do is get it in standard form. That's the first step, which is get 0 on one side. So right when I see that it's degree 2 or degree 3, you want to get 0 on one side. That's what you want to do. And so here's the leader, and the leader's already positive. So I'm going to leave the leader alone because I want the leader positive. If I move the leader to the other side to get 0 on that side, then my leader will be negative, and then I'll have to handle that. And so I leave the leader positive, and if the leader is negative, I move it so that it is positive. So this side I want to make 0. So this guy knows he's the leader. This guy knows he's the last term. This guy knows he's the middle term, right? This guy knows he's the last term. So when I go to take away 21z, I know that I'm going to put it in the middle between these two because he knows he's the middle. And when I add 3, I know that I'm going to line that up with the 3 right there. So that when the dust clears, I get 14z squared minus 21z. -3 plus 3 is 0 equals, so that was nice that was 0, actually, friends, equals 0. And so if that had been a number, that would have been fine too, and I would have gone on. But, you know, the story is, I think it's easier to factor a binomial than it is to factor a trinomial. So since that wasn't a number, because it was 0, it's a binomial. And I think a binomial is easier to factor. So that's where I'm at now, is I'm on factor. So this, I'm just writing out what I'm thinking that I'm going to do. And I notice, oh, it's a binomial. And so it could have been a trinomial had this not been 0. So I kind of consider that kind of lucky that it turned out that way. And how you factor a binomial is, first you ask yourself if there's a greatest common factor. Losing my voice too. All done? Wow, awesome. That's awesome. Do you think I could have some water? Mm-hmm. Maybe with straw too. A metal straw, friends, because I love turtles, not a plastic straw.
You can check her later.
Okay. So, the greatest common factor, I hope you thought about it while I was negotiating for water with the metal straw. And so is 14 is the smallest number, but 14 doesn't go evenly into 21, and you can, of course, put it on your calculator to see that it doesn't, right? No, it doesn't go evenly. But things that divide evenly into 14 are 7 and 2, and 7 does go into 21. And they also have z in common. So this does have a greatest common factor of 7z. So what you do is you put the greatest common factor in the front, 7z. And this is going to be 2z. Oh, my 2's and my z's. Oh, heavens. I'll write my 2 like that. And then minus 3. Right? 7z times 2z is 14z squared. 7z times 3 is negative 21z equals 0. And now I have a monomial times a binomial. No matter the size, it doesn't matter. You write it as a product, and then you set the pieces equal to 0, whether the size of the piece is monomial or binomial. So 7z, my 7 almost became a z. 7z equals 0, so I'm going to solve that, or 2z minus 3 equals 0, and I'm gonna solve that, and so I'm going to divide here by 7, so I get z equals 0, and I'm going to divide here. I'm going to add 3, and I'm going to get z equals 3/2. So we have 2 answers. And typically, you have 2 answers on these, except for the time when you have 1 answer, and that's when you had a repeat. Now, the one thing that I haven't done on this whole page is check any of them, and it's because I was out of water. But now that I have water and I'm gulping it into your ear, I will be able to check them. So I'm going to check them all. And I would probably check mine at the end of the test. And so this will simulate checking them at the end of the test. So I would come here and I would check my answers to make sure that they work. And you check in the original, 9, whatever squared, equals 25. And we said that one of the answers was negative 5/3. And it's okay to put this in your calculator and have your calculator do the check on it. And in fact, I think it's a good idea because I didn't use my calculator in getting that. And so that way I've kind of used my head and my calculator. So I need the fraction, I need the negative 5/3, I need this, I need it squared, and that should be 25. And hot diggity dog, it is. So I use my calculator. And I just checked this one. Now I have to check the other one. So there's 2 answers. You got to check the other answer. So here's the other answer. Got to check them both. The other answer is 5/3. And the good news is I already sort of put that in my calculator, right? The only difference is a negative sign. And so you notice that works as well. Okay, so they both checked. So I want to check this one. This one only had 1 answer, because it was a repeat, right? And I'm going to check in the original. 0 equals 6. Oh, you're going to be out of ink. Poor baby. If I had trash in here, I'd just throw it in the trash, but I don't have trash in here. So I throw these dangerous pins down on the floor, and also throw paper down on the floor, and then I have to clean it up at the end of the day. So you put in your blank, right? And what did we say the answer was? We said it was -3. So we're slipping -3 right in here. And yeah, parentheses are implied when you substitute. If you don't use them, then you get the answer wrong quite a bit of the time. And I hope it makes you sad and you want to know what to do about it, and that's use parentheses. And so, because you want to get the right answer. So I'm hoping that this is going to equal 0, right? And hot diggity dog, it does. So I put this in my calculator, right? And I got 0. And 0 equals 0. It worked. Okay. So here I am checking. So I wrote up there, check, 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 check. Okay, so this one, 14z squared minus 3 equals 21z minus 3, right? I'm going to have to check both answers. So when I check 0, this is going to look like 14 times 0 squared minus 3 equals 21 times 0 minus 3. Now what it means for it to be the right answer, it means the left equals the right. It doesn't mean the left and the right are equal to the same thing. Now they doesn't mean that they're the same for both of these, but the left and the right are equal to one another. But they might be, I should stop talking. So this, whatever I get over here, needs to be the same over there. And you can see that that's going to work, right? 14 times 0 squared calculator, minus 3, right? This is -3. And that side over there, I'll use a different calculator because, you know, when you have more than one, you can, right? So that side over there, the dueling calculators for the right and the left. It's almost as good as dueling banjos. Go check it out. The dueling banjos, right? And so on YouTube, you can see that. So both sides are -3. Great. Okay, so then the other one was 3 over 2. So 14 times 3 over 2 squared minus 3 equals 21 times 3 halves minus 3. So when I put this in, instead of 0, I'm going to put 3 halves. So 3 halves like that, 3 divided by 2. Or if that drives you crazy and you say, oh, you could use the fraction key like this. And so whatever, it doesn't matter. So this side's 57 over 2. So what I was trying to say is that I don't expect that I'm going to get -3. That's what I was trying to say when I was saying that they weren't going to be the same. I was saying that when I put in 3 halves, both sides might not be equal to 57 over 2. Over here, see, they have to be the same here. But this and this need to be the same. So dueling banjos. So instead of 0, I'm going to come here and I'm going to put in 3 halves. And I get 57 over 2. Is everything good, Cat Ty? Yeah? Okay, good. And so, hot diggity dog. So that's example number 4. And so those were good answers. And so we did a lovely job at that. So we have 2 more examples to do here. And what makes these examples more fun is that they're a little bit harder to factor, right? So I can see that it's degree 2. So degree 2, degree 1, degree 0. So this is degree 2. And any time that it's degree 2, you want to get 0 on one side. So this is my thoughts. Get 0 on one side. And so this is my leader, and so I'm going to take away 2. So I get 12y squared minus 5y minus 2 equals 0. And I'm like, ooh, it's a trinomial, and I got to factor it, right? And we practiced our factoring. I always think greatest common factor no matter the size, but 2 is the smallest number, and it doesn't go into 5. Yeah, so it doesn't have a greatest common factor other than 1, so that means do nothing. So now I'm trying to unfoil because it's a trinomial. And you can use AC factorization or diamond couple or whatever, whatever floats your boat. 1 times 2 is 2. And it could be, to make 12, it could be 1y and 12y. It could be 2y and 6y. It could be 3y and 4y. And I don't have to list them all. I only have to list what I plan on trying. And so I'm thinking I'm going to try 3y and 4y first. And the reason I wasn't so keen on trying 2 and 6, do you remember that 2y and 6y? Do you remember that common factor thing? There'd be no place to put the 2, right? And I'm thinking 12 is going to be a little bit too big to try to make 5 in the center, with the other ones being a 1. And so I don't know. So I was thinking I kind of needed to go more things that are kind of closer together. So I was thinking maybe 3y and 4y. Now, because of the common factor thing, I know that the signs, right, the signs are 1 positive and 1 negative because that's a subtract there. And I know that they're going to subtract back down to 5. And I was thinking, I don't know which one's the plus yet and which one's the minus, but I know the 2 can't go in here because of the common factor thing. So the 2 has to go over here and the 1 has to go there if it works. If it doesn't work, I'm going to try something else, right? So I already know I have the first working and I have the last working. I'm going to put 1 positive and 1 negative in there. And what's going to help me decide that is what goes on here. So this is 3y and this is 8y. And when I subtract them, that's a subtraction sign. So that's why I am subtracting them. When I subtract them, I want to get 5y. And so one of these is a plus and one of these is a minus. That's how it becomes a subtract. And I want the bigger one to be minus because the 5 in the center. So I have to have this be minus so that I get the subtract on the 8y. And this be a plus so that I get the plus on the 3y. So that when I put those together, I get negative 5y. So I got that factored. If you're having trouble factoring these type, always come and see me. I'll help you. And we'll get you going. The third step is to set the pieces equal to 0 and solve them. So this is 3y minus 2 equals 0, or 4y plus 1 equals 0. And you solve this, add 2, buckle your shoe, divide by 3, y equals 2/3. That's one answer. Take away 1, 4y equals negative 1, divide by 4. So we get y equals negative 1/4. So those are my 2 answers, 2/3 and negative 1/4. And of course, you should check it. And so at my house, it's really, really late, and I have 3 calculus videos yet to make. So I'm going to let you check it. I bet you can. I know you can. I got confidence in you. So I bet it works. I hope it works. I hope I don't start thinking I need to check it to make sure that it works. Okay. Now, somebody factored that for me. But they weren't too sweet to me because they forgot to do something. What did they forget to do? Yeah, they forgot to get 0 on one side. So basically, it's not helpful that it's factored because it doesn't have 0 on one side. So what you need to do is you need to multiply this together, then take away 14 so that you'll have 0 on one side, and then refactor it, and then that'll get you your answer. So unfortunately, this crazy thing isn't solvable because even though it's factored, there's not 0 on one side. So I'm going to have to multiply this together, 8t to the second minus 2t. So this is incorporating my chapter 4, plus 4t minus 1 equals 14. And then I'm going to put this together. These are like terms, right? There's the middle term. And I'm going to take away 14, so I get 0 on one side, so that I get it in standard form for a quadratic, which is 0 on one side. So this is 8t squared plus 2t minus 15. And then now I'm going to try to give a factor to that thing. So I'm like, oh my gosh, am I going to factor that? Okay, does it have a greatest common factor? I see it has 3 terms. Does it have a greatest common factor? No, it doesn't, darn. So let's see, to make 8 is probably 2t and 4t, but it might be 1t and 8t. To make 15 could be 1 and 15, but I bet it's 3 and 5. I'm gonna go with 3 and 5. And I know that the signs are 1 positive and 1 negative, right? And I'm just going to give a try to this, and if it doesn't work, I'm going to cry, I'm going to whine. No, I'm going to do neither one of those. I'm going to start again and see if I can think of what it might be. Okay, so I want 2. I want it to subtract to be 2. So I'm kind of thinking, if I put the 5 here, it'll multiply with the 4 and make 20. And my worry is that 2 times 3 is only 6. So I'm thinking kind of, because I kind of want the numbers almost to be the same size, because when you subtract them, you get 2, which is almost the numbers being the same size. I'm thinking I got to put the 3 here, and that gives me a 12, and the 5 here, and that gives me a 10. Do you guys see how the outer is giving 10t rather? And the inner is giving 12t. And remember that they were going to subtract. So I want 12 to be positive because I want the middle to be positive. So 12's got to be positive and that's got to be negative. So this is my negative and this is my positive. And I got it factored. And I check it to make sure that I factored it right. I FOIL it out and make sure. And I think you should too. And so I want you to know that right now I FOILed it in my head and I said, okay, when I do that, I get 8t squared. Okay, here I get negative 10t. Here I get positive 12t. When I put those together, I get positive 2t. When I do this, I get negative 15. Hot diggity dog. Okay, I got factored. Now you do the 0 thing. You set the pieces equal to 0 and you solve them. And the good news is that's what we did in chapter 1, right? All we have to do is, these are always easier than the chapter 1 ones. You just take away 3 and divide by 2. They're only 2-step. These were the ones that we had in chapter 2 chapter 1 got to be quite a few steps, some of them, where these are 2 steps. That's a dance too, if you want to do it. Okay, 5/4. Right, so this is our 2 answers, and so we did a lovely job on that. And you can check it. Remember, I said that it's a good idea to check, and so right here is the check, right? And I said that I wouldn't get crazy and check it, and I would let you check it and make sure that they both worked. Anyway, I don't think I'm going to get crazy and check it anyway. We'll see. Tell me if I got them right or wrong. And so I'll talk to you guys later. I think they're okay. Bye-bye.